Okay, so we are going to be looking at lesson 3 of unit 1. We're adding and subtracting polynomial expressions. We've already completed page 8 in class or on Zoom. So we are going to look at example 3, and we're going to work through example 3, and then let's see, 3 through 7. So for example 3, it says simplify and name the polynomial expression, then write in standard form. So what we need to do here, we have an addition sign in the middle of these two sets of parentheses. So whenever you have that addition sign, if there's nothing in front of your parentheses, no number or anything, you don't have to distribute. All you want to do here is you want to rewrite everything out basically without the parentheses. Honestly, the parentheses in this case are not necessary. Okay, so we have everything written out, but it says to simplify in the directions. So if we are supposed to simplify, we have to combine all our like terms. So our highest exponent is a 2. So we're going to look at all our x to the seconds. We have negative 5x squared and we have 3x squared. So if we combine those, negative 5 plus 3, we get a negative 2x squared. Then we want to look and we have our x and we have a negative 10x. So those are also like terms. So really there's like a 1 in front of this x. So we're going to say 1 minus 10 gives me a negative 9. We keep our x. Okay, and the last thing that we need to look at is our constants. So we have a negative 4 and we have a positive 6. So if we combine those, negative 4 plus 6 gives me a positive 2. In looking at this expression, our highest exponent is 2, so that would make this a quadratic. And then we have 3 terms, so it would be a quadratic trinomial. Okay. Looking at example 8, it gets a little more tricky because we have a negative right here. If you have a negative in front of a set of parentheses, you have to distribute a negative 1, or you have to distribute that negative into your parentheses. So basically, we're going to take everything from this set, and we're going to rewrite that. Okay. Then we're going to take that negative 1, and we're going to distribute it to everything in my parentheses. So negative 1 times 6m to the third gives me negative 6m to the third. And then negative 1 times 4m squared gives me negative 4m squared. Okay. Now we can go ahead and we can combine our like terms. So our highest exponent is a 4. So we're going to look and we have 7m to the fourth, but we don't have any more m to the fourths. So we're just going to bring that down. Then we want to look and say, okay, well, I have an m to the third now, and I have a negative 6m to the third. So that m to the third really has that imaginary 1 in front, so we really have 1 minus 6 gives me negative 5m to the third. Then the last thing we have is this negative 4m squared. There's no other m squared, so we're just going to bring that down as well. And in this case, we have a highest degree of 4, so this would be a 4th degree. And then we have 3 terms, so that would be a 4th degree trinomial. Okay. Looking at letter C, let's see here. We have a plus sign here with nothing, no number in front of any of the parentheses, so we're not distributing anything. So this is more like example A. We're just going to rewrite everything. We have 6x minus 3x squared plus 3x squared minus 12x minus 3. Now at this point, we want to look for our highest exponent since we are wanting to put this in standard form. So we look and we have negative 3x squared and we have positive 3x squared. Well, if you have the negative of a number, so negative 4 plus 4, that's going to give you 0. Okay, so in this case, we have negative 3 plus 3, which gives us 0x squared. 0 times anything is 0, so really what these are doing, they're going to cancel each other out. Okay, so once we cancel those out, we want to look at 6x then and negative 12x, because those are our next highest degree, and those are like terms. So 6 minus 12 gives me negative 6, and I have to keep that x there. Okay, then we have our constant negative 3, and there are no more constants, so that's just going to be a minus 3 there. And in this case, our highest degree is that like imaginary 1 there, which I don't want you to put. I want you to get in the habit of not putting that 1. But just to tell us what the name is, it's nice to know that there is a 1 there technically. So this is a linear. And then we have 2 terms, so that's going to be a linear binomial. Okay. All right, let's look at the next one. So we have a minus sign here, okay? So anytime we have that minus sign, we have to distribute that into our parentheses. So it's like having a negative 1. Now everything in front of that negative sign, that can just be rewritten because there's nothing here to distribute. Okay, so then we're going to distribute that negative 1. Negative 1 times y is just negative y. And negative 1 times negative 13 becomes a positive 13 because whenever you multiply two negatives, you get that positive. Now, basically, what you're doing whenever you're distributing that negative 1 is you're changing your signs. So this was positive in my parentheses, it became negative. This was a negative 13, it became positive. Okay, so basically all you're doing is flipping all the signs. Okay, so then here we have a y minus a y. And just like we saw here in example C, those cancel each other out. Okay, then we're left with that 15 and 13. So if we add those together, we're going to get 28. And that's just a constant. Okay, it's just a number, so we call that a constant. Okay. Moving on to letter E. If you look at letter E, we have that negative sign here in the middle again, so it's like multiplying that negative 1. Everything in front of that negative sign is going to just be rewritten. Okay, and that negative 1 is going to distribute to every term inside my parentheses. So I'm going to take negative 1 times 3x squared, and I get negative 3x squared. So again, just changing all my signs. So negative 1 times 4x is going to be negative 4x. And negative 1 times 2 is going to give me negative 2. Okay, we want to look for our highest exponent like we have every time. So we look and we have an x squared here, and we have one here as well. So we're going to combine those. 5x squared minus 3x squared gives me 2x squared. Okay. Then I have negative 6x minus 4x gives me negative 10x. And then if you look here, we have an 8 and a negative 2. So 8 minus 2 gives me a positive 6. So my highest exponent here is a 2, which makes this a quadratic. And then I have 3 terms, which makes it a trinomial. Okay, let's move on here to example F. Okay, so if we look at example F, we have that negative sign there again. So again, we're going to be distributing that negative 1. Everything in front of that negative, we're going to keep the same. Okay, that negative 1 times 3x squared becomes negative 3x squared. And negative 1 times 2 is going to become a negative 2. Okay, so if we have basically a negative 1x squared here, and negative 3x squared. That's going to end up being negative 4x squared. And then we also have 2 minus 2, which is just 0. I don't want to put plus 0 there, but that's unnecessary. We don't need to add 0 or subtract 0. It's still going to give us the same thing. So in our simplified standard form, we have negative 4x squared as our final answer. To name this, we look at our exponent, 2, and that is a quadratic. And then the fact that we only have one term makes this a monomial. If we're unsure of our names, we need to make sure that we are practicing with those names so that we know how to name those these expressions. Because that is not going to go away. That is going to stay for the entire semester, or I'm sorry, entire unit. Okay, let's go ahead and look at G. Here we do have that negative, but the problem is we can't just rewrite x to the third plus 8x here. We can't just rewrite that because we have this 3 in front. So we need to distribute first. So we're going to take that 3 times x to the third, and we get 3x to the third. Then we take 3 times 8x, and we get 24x. Okay. And then we can't just distribute a negative 1 now because there's this negative 2 here. Okay, that negative 2 is what we're going to distribute to everything in this set of parentheses. So we take negative 2 times 3x squared, and we get negative 6x squared. Negative 2 times 4x, and we get negative 8x. And then negative 2 times a positive 2 gives me a, oh, I messed up, gives me a negative 4. Okay. And then this is where we're going to have to combine our like terms. Our highest exponent here is 3, but we have no other x to the third. So we're just going to put 3x to the third. We're going to bring that down. And then my next highest exponent is not this 24x. My next highest exponent here is a 2. So I'm going to look at that negative 6x squared. There's no other exponents that are 2. So we can't combine it with anything. We're just going to pull that down as well. The next thing we have is our 24x and negative 8x. So 24 minus 8 is 16. And we keep that x. And then, oops, yeah. And then I have this negative 4. No other constants, so I just pull that down as well. My highest exponent is a 3. So this is going to be a cubic function. And I have 4 terms. So this is a cubic 4-term polynomial. Okay, let's go ahead and let's look at H. So with H, again, we have this positive sign here. We don't have a number in front here, and we don't have a number in front here. So we're not distributing anything. And whenever you have that positive sign, all you have to do is basically rewrite everything out without the parentheses, because they are unneeded in this situation. We have a lot of terms here. And we need to start combining some stuff. Okay, so my highest exponent is a 3. So I'm going to look at this 2x to the third and 9x to the third, and that gives me 11x to the third. Then I need to look at my x squareds, and I have 6x squared and 11x squared, which combines to give me 17x squared. And then I have 10x and 3x, which combines to give me 13x. So if I look at my highest exponent, it is a 3. So again, this is going to be a cubic function like the last one we did. And instead of having 4 terms like the last one, this one only has 3, which makes this a trinomial. Excuse me. All right. Looking at letter I, this time we have that negative sign here. There's no numbers in front of my parentheses, so this is just like a -1. Okay, everything in front of that negative, we're just going to rewrite. Okay, and then that -1, let's go ahead and let's distribute that. So again, it changes all of the signs for every term inside that parentheses. Okay, so we have -1 times t to the third gives me -t to the third. We have -1 times 5t squared, which gives me -5t squared. -1 times 4t gives me -4t. And then I have -1 times 7, which gives me a +7. So once we've done all our distributing, we can go ahead and combine those like terms. Our highest exponent is 3, so we're going to start with that. We have 3t to the third minus t to the third, which is really like subtracting 1t to the third. So we have 2 total t to the third. Excuse me. Then here we have -t to the second and -5t to the second. That's a -1 basically. So -1 minus 5 more is -6t to the second. We can't forget about this -4t here. There's no other just t terms, so we're just going to rewrite that, and we're going to bring that down. And then we have 8 plus 7, which gives me a +15. Again, our highest exponent here is a 3, like it has been the last couple times, so it is a cubic. And we have 4 terms here, so it's going to be a cubic 4-term polynomial. Okay, the last one we have here has 3 different sets of parentheses, and it has plus signs everywhere, so that's a plus. We don't have to worry about any negatives. But there's no number in front of this set of parentheses, so we're just going to bring that down. We have 3p plus 1. Now the second set of parentheses here, p minus 8, we have that 6 in front, so we need to distribute that 6 into our parentheses. If you can distribute first, you always want to do that. So we have 6 times p, which is 6p, and then 6 times -8 is -48. And then with this last set here, we don't have anything in front of that set either, so we're just going to bring that down as well. Keep all of our signs the same. Okay, and we're going to start combining. So we have 3p, 6p, and p, which is really like a 1p. So if we add and combine 3 plus 6 plus 1, we get 10p. Then we have 1 minus 48, which is -47, plus 2 gives me -45. Okay, and in this case, that p really has that imaginary 1 as an exponent, so that makes this a linear. 2 terms we have, so it's going to be a linear binomial. Okay, so we've done a lot of distributing and simplifying and adding and subtracting. So we're just kind of going to put that into some word problems here at the end. So if you look, let's see, at number 4, it says, write a simplified expression for the perimeter of a rectangle. So I'm just going to draw out my rectangle. Okay, so I have my rectangle. And it says it has the given side lengths of 3x plus 6 and 2x plus 5. So if you look at a rectangle, opposite sides are congruent or the same. So that means basically if this side is 2x plus 5, this side has to be 2x plus 5. Okay. Then it says our other side length is 3x plus 6. So basically if this side is 3x plus 6, the opposite side has to be congruent or equal to that, so it also has to be 3x plus 6. okay? And it's asking us for a simplified version or a simplified expression of the perimeter, okay? And perimeter is the distance around a figure. So basically, you're adding up all of your sides. So I'm going to take 2x plus 5 plus 2x plus 5 plus 3x plus 6 plus 3x plus 6. I have all of these things that I need to add together. So I'm going to start combining like terms. 2x plus 2x plus 3x plus 3x. That gives me 10x total. And then I also have 5 plus 5 plus 6 plus 6. And that's going to give me 22. So this right here would be my simplified perimeter, or simplified expression for my perimeter. Okay. Then if we look at example 5, it's pretty similar. It's just more word. This is more of a word problem. It's not giving you the lengths like it did here in example 4. So it says, write a simplified expression for the perimeter again of a rectangle. So we're going to draw a rectangle again. It's always easier if you draw a picture. Oops, what happened? Okay, there's my rectangle. Okay, and it says with a length that is 2 more than 5 times the width. So if we're talking about width, I'm just going to make width x. So I'm just going to make, if this is my width here, okay, I'm just going to make that x, which means that the other side has to be x because we're talking about a rectangle. But then it says the length is 2 more, so plus 2 here, 2 more than 5 times the width. Okay, 5 times is like taking 5 times whatever the width is. And in this case, our width is x. So we're going to take 5 times x, basically. And then we say 2 more than that. So if we have 5x, we're going to say plus 2, because we have to have 2 more than that. This is also going to be 5x plus 2, because opposite sides are congruent or equal, like we did in example 4. Okay, so we're going to just add everything up just like we did again in example 4. We have x plus 5x plus 2 plus 5x plus 2. And again, we're just going to combine all our like terms. So we have x plus 5x plus 5x. That gives us 12x total. And then we have 2 plus 2, which gives us 4. So my simplified expression for the perimeter of this shape is going to be 12x plus 4. Okay, let's go ahead and let's look at example 6. So with example 6, guys, this one is a little bit tricky because we don't know all the terminology that goes with this question. Again, we're talking about perimeter, and that's the distance around the shape. Okay, but then we're also talking about an equilateral triangle here. And you guys have probably heard that before, but just as a reminder, an equilateral triangle is a triangle that has all congruent sides. So, oops. Every side is equal in an equilateral triangle. Okay. So it says one of the side lengths is x to the third plus 2x squared plus 2x to the 0 power. Now, we also kind of talked about this a little bit, but I just want to reiterate that x to the 0 power is just 1. Anything to the 0 power is 1. So if this is just 1, that's like taking 2 times 1, which is just 2. So really that x to the 0 power there is just to kind of throw you off. So really every side of our equilateral triangle is x to the third plus 2x squared plus 2. And that goes for every side, oops, of our triangle. Okay. So Using the distributive property, we can actually make this a little bit shorter than writing out every side 3 times, okay, and adding them together like we did in examples 4 and 5. We can actually say, okay, well, here we have 3 sides, and they are all the same. So I'm just going to take 3 and multiply it by my side length. Since I have 3 of them, this should give me my perimeter. Now we know how to distribute. We're going to go ahead and take that 3 and multiply it by everything inside my parentheses. So I have 3 times x to the third, which is 3x to the third. 3 times 2x squared, which gives me 6x squared. And 3 times 2 is going to give me 6. Okay, this right here, I'm done. This is my simplified perimeter of my equilateral triangle. You also could have written this all out. So you could have written that out 3 times and then combined your like terms, which would have been absolutely fine as well. That was just a simpler and shorter way to do it. So I wanted to show you the shortest way to possibly get that problem done. If you would have written it all out and combined your like terms, you still would have gotten this answer. Okay. Number 7 looks like a lot of words, but it's actually not as hard as what it looks like. So example 7 says, give an example of a 5th degree. So my highest degree is 5. And then it says binomial, which means that I have 2 terms. Okay. It says with this following criteria. So we have to meet the criteria for this one and this one. Okay. And it says if it's not possible, just state that it's not possible. So the coefficient, so the number in front of the variable, of the quartic term. Quartic means 5. That means 5th degree. Okay. It's just a... just another word for it. So the coefficient of the 5th degree term is negative. It's also an even integer, so we have to have it negative, we have to have it even, and we also have to say that it's divisible by 3, but not by 4. Okay, so I'm going to start out by making it negative, because we know it has to be negative. And then it says, well, it needs to be divisible by 3, but not by 4. So I'm going to say, let's try 6. 6 is divisible by 3, but you can't divide it evenly by 4. And it is that even integer that we also had to have. So I'm just going to stick an x to the 5th since this needs to be my quartic term. Okay, so that would work. But then for the second part of this, it says the coefficient of the linear term is a multiple of 24 that is odd. Okay, anytime you have a number like this, 24, an even number, if you double it, it's going to give you another even number. If you triple it, it's going to give you another even number. If you quadruple it, it's also going to give you another even number. So if you keep going, it's going to give you an even number every time. So if you have a multiple of 24, it's never going to be odd. So really, it could meet the first criteria, but it cannot meet that second criteria. So this is just not possible. Okay, and we don't have to come up with anything because we have determined that this is not possible based on this second criteria. All right, that is it for page 10. That is it for lesson 3. Make sure you come tomorrow with questions so that we can answer those in class. All right.